Your Snowflake RBAC is configured correctly. Your Databricks unique catalog roles are set up. Your identity provider handles authentication. And somewhere in your organization right now, an analyst is querying a table with unmasked PII. Not because your permissions were wrong, but because the system enforcing those permissions had no idea the column was sensitive. The permissions were technically correct. The governance decision was wrong. That's not a configuration failure. It's an architectural one. Most data teams treat platform native access control as governance. They spend weeks mapping roles and schemas in Snowflake, configuring Unity Catalog in Databricks, wiring in Okta and Azure AD. And when the setup's done, they think the governance problem is solved. The platforms say so. The architecture diagrams say so. And in a specific, narrow sense, they're right. But governing who can touch your data isn't the same as governing whether they should. And the difference between those two questions is exactly where enterprise data governance fails. Quietly, systematically, and at scale. We've watched data teams build technically airtight access controls in Snowflake and Databricks and then spend months trying to understand why analysts are still querying deprecated tables, why PII is appearing in dashboards it should never reach, and why governance reviews feel like forensic archaeology rather than routine assurance. The permissions were correct, the governance was missing. Those aren't the same problem, and conflating them is expensive. The dominant view is coherent, well-reasoned, and backed by significant platform investment. Snowflake and Databricks have both built enterprise-grade access control layers that would have seemed ambitious a decade ago. Snowflake's RBAC system lets administrators define granular role hierarchies, apply column-level masking policies, enforce row-level security, and manage credentials with precision. Databricks Unity Catalog goes further in some respects, providing a unified governance layer across the Databricks lakehouse with table-level permissions, row filters, column masks, and audit logging baked in. Both platforms integrate with enterprise identity providers. Both support fine-grained privilege grants. Both have invested in making this work at the scale that large organizations actually run. Given that, the conventional wisdom is predictable. Govern at the source. If you control who can query which tables in which schemas across your warehouse and lakehouse, you've governed your data. The catalog in this model is a documentation system, useful for helping analysts find tables, maybe useful for tracking ownership, but not a governance control plane. Governance lives in the platforms because that's where the data lives and where access actually gets enforced. This view has genuine strengths. Platform native governance is fast to enforce. Rules apply at query time with no round trip to an external system. It's also auditable in ways that matter for compliance. Snowflake and Databricks both produce query logs and access history that satisfy most regulatory requirements. And it's technically precise. Role grants and masking policies operate on exactly the objects they're defined for, with no ambiguity about scope. The conventional wisdom isn't wrong about what platform governance does. It's wrong about what platform governance is sufficient for. The first way it breaks down is translation. Business access intent is expressed in business language. The marketing team should see acquisition data but not revenue figures. Or any column tagged as PII should be masked for everyone outside the privacy team, regardless of which system it lives in. Source systems don't speak that language. Snowflake knows about databases, schemas, tables, columns, and roles. Databricks Unity Catalog knows the same thing. Neither has a native concept of a business domain, a sensitivity classification maintained in a catalog, or a cross-system policy that should apply simultaneously to a Snowflake table and a Databricks Delta table containing the same logical data. The mechanism of failure here is the translation gap. Someone, usually a data governance manager or a platform engineer who straddles both worlds, sits between the business intent and the technical implementation. Manually translating PII columns should be masked into a Snowflake masking policy on this schema and a Databricks column mask on that table. That translation is done correctly at a point in time. Then the schema changes. A new column appears. A table gets migrated. The business policy is updated. In the translation, which was never automated, drifts. The permissions remain technically correct. The governance becomes incorrect. No alarm fires. The second breakdown is deeper. Platform governance is blind to the metadata layer. When a data steward certifies a table as production ready in a catalog, Snowflake doesn't know. When someone links a business glossary term to a column, Databricks doesn't know. When an asset is tagged as confidential or PII or restricted in a catalog, that tag doesn't exist in the warehouse or lakehouse. It exists in a separate system that the access enforcement layer can't see. This means platform governance can't answer questions like, should analysts be allowed to query uncertified tables? Should columns tagged as PII in the catalog trigger masking rules in Snowflake? Should a new team's access request for confidentially tagged assets require approval before it's granted? These questions require business context that platform RBAC structurally cannot hold. The third breakdown is scope. Platform governance governs access to data. It says nothing about access to metadata. Who can certify a table? Who can edit its description? Who can link a term from the business glossary to a column? Who can change ownership? These actions determine whether a data catalog is trustworthy or noisy, and they're completely invisible inside Snowflake or Databricks. At small team sizes, this doesn't matter. At scale, without governed metadata actions, anyone can certify anything. Ownership records go stale, and the catalog degrades faster than it was even built. The governance gap between a catalog and the data platform it governs isn't a permissions gap. It's an intelligence gap. Data platforms are making access decisions without the business context that determines whether those decisions are actually correct. This reframe matters because it changes what teams are trying to build. If the gap is a permissions gap, the solution is more configuration, more roles, more masks, more RBAC refinement. If the gap is an intelligence gap, the solution is architectural. The catalog's metadata needs to be computable inside the data platforms, not just readable by humans looking at a separate interface. Consider what computable means in practice. If a column is tagged PII in a catalog, and that tag only exists as text in a documentation UI, a human can see it, but the Snowflake masking policy, it can't act on it. The intelligence is present, but inert. If that same tag is queryable inside Snowflake, if the catalog's metadata store is exposed as a first-class data source that Snowflake can query, then governance logic can reference it directly. A masking policy can ask, is this column tagged PII in the catalog? And get an answer at query time. The intelligence becomes active. The same principle applies to the cross-platform policy problem. If business access intent is encoded only in per-system RBAC configurations, each system's governance is independent and drift is inevitable. If business intent is encoded once in a catalog-level policy model, a person that says the marketing analyst group can see acquisition assets but not financial assets and can't see PII column values across all connected systems, and that policy is enforced by a layer that sits above both Snowflake and Databricks, then the translation gap disappears. The intent is written once. The enforcement follows the data. The trade-off is real. This architecture requires a catalog that's more than just a documentation system. It requires a catalog with a policy engine, a tagging model that propagates across connections, and a metadata store that can be exposed as a queryable data source inside the platforms it governs. That's a higher bar than most catalogs are currently built to meet. Teams that adopt this reframe will spend time they wouldn't otherwise have spent on catalog configuration, tag taxonomy design, and metadata sync architecture. The payoff is governance that's structurally correct rather than procedurally maintained. Policies that hold as schemas change and teams grow rather than configurations that drift. The clearest evidence that this reframe is operational rather than theoretical comes from examining what the intelligence gap looks like in practice when it's closed. One way teams have operationalized the cross-platform policy argument is Atlan's persona model lets a governance administrator express business access intent as a single policy set that applies simultaneously across every connected system. A persona bundles users and groups with metadata policies, governing who can certify assets, edit descriptions, or add tags, and data policies that restrict or allow query access and data preview. A separate construct called purpose fires masking and deny rules based on tags applied in the catalog. A column tag PII in Atlan automatically falls under whatever masking rules have been attached to that purpose, regardless of which connection the column lives in, regardless of whether it was tagged today or 2 years ago. A governance administrator who wants to express the marketing analyst team shouldn't see PII column values across Snowflake and Databricks writes that policy once in Atlan and the enforcement follows. Neither Snowflake's RBAC system or Databricks Unity catalog has a native concept of an Atlan tag. The masking rule can't exist in either platform alone. The policy layer has to sit above both. The second evidence point addresses the intelligence gap directly. Atlan exposes its metadata store as a queryable data source inside Snowflake and Databricks, not as a documentation URL, as actual data. In Snowflake, this works through a catalog-linked database connected to an Iceberg REST catalog endpoint. Standard SQL queries against the metadata store return Atlan asset metadata, certification status, ownership, tags, and lineage directly inside Snowflake. In Databricks, the same metadata is accessible through foreign Iceberg tables auto-created in Unity Catalog, queryable with standard SQL. The architectural implication is significant. When metadata is computable, it can participate in data pipelines, power AI applications built on the platform, and inform automated governance decisions. An analyst inside Snowflake can write a query that joins operational data with Atlan metadata to surface all certified financial tables owned by the finance team that contain PII-tagged columns, and as a query result, not a manual audit. That's a structural capability, not a documentation feature. The third evidence point is the metadata governance layer itself. The scope gap, policy governance being blind to who can change metadata, is closed by a distinct policy model that governs catalog actions specifically. Atlan's role hierarchy sets a hard ceiling. A user assigned the guest role can't add tags, remove business terms, update custom metadata, certify assets, or change ownership, regardless of what persona policies apply to them. A governance admin subrole lets organizations delegate metadata governance authority, granting the ability to manage tag terms and policies without granting full workplace administrator access. This means the catalog itself has a governed trust model. Not everyone can certify anything, and the record of who certified what and when is maintained separately from the data platform's query logs. Taken together, these three capabilities operationalize the reframe at each of the three failure modes identified earlier. The translation gap is closed by a single cross-platform policy model. The intelligence gap is closed by making catalog metadata computable inside the platforms. The scope gap is closed by a separate governance layer for metadata actions. If teams want to adopt this reframe, several things change structurally, not just procedurally. The first is where governance work gets done. Right now, most teams do governance work inside each platform. A Snowflake administrator manages Snowflake roles, a Databricks administrator manages Unity catalog permissions, and someone in a spreadsheet somewhere maintains the mapping between those configurations and the actual business intent. Under this mental model, governance work moves to the catalog layer. Governance administrators write intent-based policies once in the catalog, and those policies propagate to the platforms. The platform administrator role shifts from authoring access rules to maintaining connectivity and confirming that catalog level policies are reaching the platform correctly. The second change is the unit of governance. Platform governance is table and column specific. Access is granted to a table, a column is masked. Catalog governance is context centric. Access is granted to a business domain, and everything tagged PII is masked. This changes the vocabulary of governance conversations. Instead of, does this role have select on the schema, the question becomes, does this person have access to this domain? And does this purpose match the sensitivity tag columns within it? That vocabulary shift takes time to establish in organizations that have been doing the table level RBAC for years. But it's worth doing because it's the only vocabulary that survives platform migration, schema changes, and team restructuring without constant manual reconfiguration. The third implication is that data quality and data access governance converge. When certification status is a queryable property inside Snowflake and Databricks, organizations can build access logic that references it. A pipeline that only promotes certified assets to a production schema is now a SQL query, not a manual approval process. A dashboard that surfaces all production flag tables owned by teams without active data stewards is now a Snowflake query against catalog metadata, an early warning sign for governance debt, not a quarterly audit. Teams that have made this shift report that governance stops being a compliance exercise and starts being an actual operational signal. That's the downstream difference between a documentation system and a computable catalog. The diagnostic question is specific. When a Snowflake or Databricks platform makes an access decision, does it know whether the asset being queried is certified, who owns it, whether it contains PII according to the catalog's taxonomy, and whether the requesting team has been granted access at the business domain level? Or does it only know the user's role in the table schema? If it's the second, the team is operating from the old mental model, and the governance gap is open. The first decision most teams can make differently right now is to separate two governance questions they've been treating as one. Can this user access this table is a platform RBAC question. Should this user access this table, given everything the team knows about the asset and their context, is a catalog question. Separating these questions isn't a technology change. It's a framing change that can happen in the next governance review meeting. Once the questions are separated, the gaps in the current architecture become visible without requiring a platform migration to see them. The longer path is architectural. Teams that fully adopt this reframe will invest in three things over the next 6 months. First, a tag taxonomy in the catalog that's authoritative, not descriptive labels that humans read, but governance active tags that fire masking and access rules. Second, a persona and purpose model that encodes business access intent in the catalog layer rather than distributing it across platform RBAC configurations. Third, a metadata sync architecture that makes catalog metadata queryable inside the platforms themselves. So governance logic can actually reference certification status, ownership, and tag presence at query time, rather than requiring a human to check the catalog separately. None of these investments are small. All of them pay dividends that RBAC configuration alone can't produce. The question to bring back to the team this week: when the catalog knows something about an asset, that it's PII tagged, uncertified, owned by a team that no longer exists, does that knowledge reach the data platforms? Or does it stop at the catalog UI? The gap between those two answers is what this video has been about. Platform RBAC governs access. Catalog intelligence governs trust. Running one without the other means platforms are making access decisions with half the information they need. If you want to go deeper on how the persona and purpose model handles cross-platform PII masking specifically, and where the enforcement architecture gets complicated, that's worth a dedicated look at how tag-based policies interact with platform query proxies.